Okay, we're going to talk about section 6.5 and learn how do you graph square root and cube root functions. So this section is graphing, so you're going to need graph paper. The parent function. Remember, a parent function is the simplest function of a family of functions. So the simplest square root function is y equals the square root of x. So if I was to graph that, I'm going to simply make a table. And when I choose values to plug in there, it would make sense for me to choose values I can square root. Okay? Like 0, 1, 4, and 9. Those are numbers I can square root. Square root of 0 is 0. 1, the square root of 4 is 2. Square root of 9 is 3. Can't use negative numbers because I can't square root a negative. So I plot those values. 1, 1. 4 is 2. 9 is 3. So it looks like that. And that's what a square root function is going to look like. Remember, the square root of x is the inverse of y equals x squared. So it's the inverse of a parabola. So you think about it, it's that parabola reflected on the line y equals x. But it's only this part of it because we can't square root a negative number, so we're not going to get any values down here. What we're going to talk about a little bit in this section and have you do is state the domain and range. So in this case, if you remember what the domain is what x values I'm allowed to plug in. What inputs can I plug into this equation? I can look at the equation and determine that the only x values I can plug in are greater than or equal to 0. Can't plug negatives in. I can see by the graph because if I look on the x-axis, I don't have any x values less than 0. My graph starts here. It doesn't keep going to the left. The range are the possible outputs, the y values. So in this case, no matter what values I plug in, my result is always going to be greater than 0. So this will be y is greater than or equal to 0. You can look at the graph by looking at the y-axis, and you can see that 0 is my lowest y value, and it increases from there, and there's no y values below 0. So that's my domain and range for this parent function y equals square root of x. Okay, the other graph, cube root of x. So this is the simplest cube root function. Let me make the table over here. This one's a little more complicated because I can plug in negative values. What would be a number that I should plug in? What number can I cube root? Well, I can cube root 8 or negative 8. So let's try negative 8. The cube root of negative 8 is negative 2. Negative 1, the cube root of negative 1 is negative 1. I can always use 0. Cube root of 1 is 1, and the cube root of 8 is 2. So those would be values to plug in here. 8 is negative 2. Negative 1 is negative 1. 0, 0, 1. 2 is 8. So this graph looks like this. Okay. And if you remember what y equals x cubed would look like, y equals x cubed looked like this. So it's that same graph reflected on the y equals x line. And that's because the cube root and the cubed are inverses of each other. Now for cube root functions, what's the domain and range? Well, I can plug positives or negatives in there, so it'd be all real numbers. Or you can say all x or all real numbers. The range, all y, because I can get any value as an output. Okay? So let's try a couple more. Let's make it a little bit more complicated. Let's graph y equals negative 3 square root of x. So again, I want to choose values to plug in here that I can square root. 0.0149. So I'm going to get 0, square root of 0 is 0, so I'm going to get 0, square root of 1 is 1, times negative 3 is negative 3, square root of 4 is 2, so I get negative 6, and then negative 9. So 0, 0, 1 is negative 3, 4 is way down at negative 6. I'm going to run out of room here, but you can see what's happening with this graph. It's going down, and it's going to level off, but that's what the graph would look like. Now, what is the domain? The domain is x is greater than or equal to 0 again, because I can't plug negatives in. The range, however, is y is less than or equal to 0 because my outputs are all less than or equal to 0. So that's what I would get on that one. Let's try this one. Okay, so again, plug in numbers I can cube root. So the cube root of negative 8 is negative 2. Times that would be 2. Or no, wouldn't it be 1? Negative 1. Cube root of negative 1 is negative 1. Times negative a half would be positive 1 half. Give me 0, 1 half. And I believe I'll get 2 half times negative a half is negative 1. So in this case, I'm going to go by 2's here. Because I didn't give myself enough room. So negative 8 is 1. Negative 1 is a half. 0 is 0. 1 is a half. And 8 is negative 1. So the graph looks like that. Domain and range. All x and all y, because again, cube root functions, I can plug anything in. So the easy thing in this section is writing the domain and range of the cube root functions. It's always the same, all x and all y. Okay, let's make this a little bit more complicated. Translating graphs. Remember what that means is moving the graphs. We can move these the same as we did the parabolas, the cubics. It's got a general equation with an h and a k. Remember, the h shifts graphs horizontally, the k vertically. The a is my stretch factor. So we can graph these pretty easily. In this case, for the square root, the hk, the coordinate of the hk is the starting point. The hk for the cube root is the middle point. Okay. So if I was to graph this one, it's a square root. My h and k, there is no k, so that's 0. So I always write down the coordinate of the hk. So in this case, the h is an opposite again. So it's negative 1, 0. So that's my starting point. Of my square root graph. And I know square root graphs always start at a point and either go up or go down. So now all I need to do is plug in a few more points. So when I make my table, in this case, I'll make it over here. I want to plug in numbers I can square root. Now we have to be careful though, because I'm adding 1 here before I square root. So negative 1 plus 1 is 0. So that's the first number I put in my table, because I'm going to get 0, and the square root of 0 is 0, times 2 is 0. Okay, now the next number I would plug in here would be 0, because 0 plus 1 is 1, and I know what the square root of 1 is. It's 1 times 2 is 2. And the next number would be 3, because 3 plus 1 is 4, and the square root of 4 is 2. 2 times 2 is 4. So I want to plug numbers in I can find the square root of. So let's see, I get 0, 2, and 3 is 4. This graph's going to look something like this in that case. Now the domain, now we got to be careful, because just because it's a square root doesn't always mean the domain is x values greater than or equal to 0. Because in this case it's not, because negative 1 works. I can plug negative 1 in here. So in this case the domain is x values greater than or equal to negative 1. Anything less than negative 1 is going to result in a negative under the square root. Okay, the other thing I can do is look on the x-axis, see where my graph starts. That's would be my domain. My range is y is greater than or equal to 0 in this case, because my lowest y value is 0 and it increases from there. Okay, let's try one more square root graph. Let's identify the starting point. It would be positive 3, negative 1. So I'm going to first start by plotting that point. That's my starting point. Okay, so now when I make my table, 3, negative 1. If I plug in 3, I get 0 there. Okay, so now I got to plug in another point. So anything less than 3 is going to give me a negative, so I can't do it. But I could try 4, because 4 minus 3 is 1. 4 minus 3 is 1. The square root of 1 is 1. Times 1/2 is 1/2. 1/2 minus 1 is negative 1/2. So be a little careful there. Next number I'll plug in would be 7. Because 7 minus 3 is 4, and the square root of 4 is 2, times 1/2 would be 1. 1 minus 1 is 0. Okay, so now let's plot those points. 4 is negative 1/2, and 7 is 0. So that's what this one's going to look like. It's flatter because of the 1/2, the stretch factor. This one is steeper because positive 2 is the stretch factor. Okay, all I need is 3 points for these graphs, and I know where they're going. Okay, what's the domain and range? Okay, so the domain is x values greater than or equal to what? Well, the smallest value I can plug in is 3. Anything less than 3 and I get negative, so it's greater than or equal to 3. And the range is y is greater than or equal to negative 1. Because negative 1 is my lowest y value, and it increases from there. So it's very important we get this starting point, because that starting point is going to identify what our domain and range is as well. Okay. A couple more. Let's try some cube root ones. Okay, so this one, my h, I don't have an h. H is 0 and k is negative 3. Negative 3. Now this is a cube root, so that's just the middle point. Okay, so let me make a table. So what other values could I plug in? Numbers I can cube root. In this case, I'm not adding or subtracting, so it's just the numbers I can cube root: negative 8, negative 1, 0, 1, and 8. So negative 8, cube root of negative 8 is negative 2. Minus 3 is negative 5. And then negative 1 is negative 1. Minus 3 is negative 4. 0 is negative 3. 1 is negative 2. 8 would be 2 minus 3, which would be negative 1. So let's go by 2's again. 8 is negative 5, negative 1, negative 4, 1 is negative 2, and 8 is negative 1. So this graph's going to look like this. Domain and range, all x, all y. So that's what that one's going to look like. Last one here. Where's my middle point? Negative 2, negative 3. So let's go by 2's again. You don't have to go by 2's if you give yourself enough room. Negative 2, negative 3. Make your table. Be very careful now because we're adding 2 to it. So instead of plugging in negative 8, I have to plug in negative 10. Because negative 10 plus 2 is negative 8. Cube root of negative 8 is negative 2. Times negative 1 would be 2. Minus 3 is negative 1. So negative 10 gives me negative 1. Check that calculation. Plot it right now. Then I'm going to try negative 3. Because negative 3 plus 2 is negative 1. Cube root of negative 1 is negative 1. Times this is 1. 1 minus 3 is negative 2. So that would be right about here. Then we'll try negative 1. Because negative 1 plus 2 is 1. Cube root of 1 is 1. Times this is negative 1. Minus 3 is negative 4. Be right here. And then finally would be 6. Because 6 plus 2 is 8. Cube root of 8 is 2. Gives me negative 2 minus 3 is negative 5. So this graph's going to look something like this. Domain, all x, range, all y. Okay, so that's how we graph these. The cube root functions are always going to be the same shape. They may be, this one's a negative, so it starts up and goes down. But that's how we're going to graph these functions.